Hi, my name is Taylor Calderon, and I'm the Chief Engineer and Project Lead of the Autonomous Systems Data Transfer Buoy. To give you a little bit of background on what our project is and what it entails, I need to first tell you the purpose behind it. Wireless data transfer opens huge windows of opportunity for information to be intercepted and stolen by outside parties. This is especially prevalent when out at sea, due to the fact that wireless transfer is the only option. The Navy came to us to try and alleviate this problem because of some of the sensitive data that they have to exchange between unmanned vessels. So what we decided was to come up with a buoy capable of acting as a center or a hub for these data transfers. In addition to being a secure location for the data to be exchanged through a hard link connection, it would also eliminate unnecessary trips for these vessels to go back to the Ranged Operating Center, or ROC for short. This would allow the vessels to focus on their mission directives with more time rather than having to spend unnecessary time traveling back to that ROC. Some of the goals and objectives of this buoy were that we needed the buoy to be able to maintain a set location for these vessels to travel to. If it is unable to maintain that location, the vessels will not be able to find it, and that data transfer cannot be established. In addition, the data must be transferred through a hard link connection. The buoy must be able to connect to these vessels through a hard link connection, and it must be autonomous. In order to make sure that everything is running as we have intended, we need a GUI, or graphic user interface, to display this. It will have a map capable of showing where both the buoys and vessels are, and in addition to that, it will also have indicator lights to indicate what steps have been accomplished throughout the process. Some of the requirements that go with these objectives are the buoy must be able to maintain a 1 meter radius set by a GPS coordinate. In addition, the GUI must show all progress of each vessel. And finally, the buoy must have a minimum of 3 connection ports. Rather than having one connection port at one location on the buoy, we decided that it needed to have it at multiple locations so that the vessels didn't have to go to a specific connection port. This eliminates any extra difficulties for establishing the hard link connection. A brief timeline for this project. The first 2 weeks we outlined the client's requests and requirements in order to ensure that we were going to accomplish what we needed to. Then we broke down the roles and the milestones of each student, what we needed to accomplish, and when we needed to have it done by. Then we began doing research on each of our parts. This was essential in ensuring that we were able to meet each requirement that the client set out for us. After our research, we began designing each portion of the project, from the structure to the control system to the graphic user interface. After this, we began with an initial prototype. This is important so that we can test each of our portions to make sure that everything is working as we have designed. After this testing phase, we go back into another redesign in order to fix any problems that we may have encountered. After this redesign, we do another stage of testing and any final modifications that need to be made. Once we have passed all of our tests, we can then do a finalized design and prepare a manual for the client. Then we can create a report and a presentation to deliver to the client. The structural progress this quarter. A full base structure has been designed. A custom rudder has been designed, and a custom motor and shaft casing for the propeller. These are the main functions of the buoy. The hard link connection portion will be established during this coming quarter. Other than the hard link connection, everything else has been established, from being able to maintain a set location to just simply floating on the water. Our graphic user interface progress has almost been complete. To the right, you see both the map and the indicator lights as was required. In addition, we added a customization option that would allow the user to pick the number of vessels that they want. Finally, we also added a send file button. When uploading new data to the buoy, the user can just hit send files and it will simply upload the files rather than having to mess around with it. The goal with this was to create a user interface that was as user-friendly as possible. We were not sure who was going to be using this, and we wanted to ensure that whoever did was able to pick it up and start using it immediately. Finally, our control system. This is the most important part of the system. Without this, the buoy is incapable of meeting any of the requirements that were set out upon us. We decided to go with a PI controller system. This allows the buoy to be controlled using both motors, the servo and the brushless. The servo is controlling the direction of the buoy, and the brushless motor controls the propeller. These turn on when the PI controller tells it, which is essentially based off the GPS system. If the GPS reads that it is outside its set location, it will send that data to our controller, which will then activate the motors. A subsystem breakdown. I myself am the chief engineer, and I also took on the structural engineer role. Our controls engineer is Chung Yang, and our graphic user interface engineer is Jia Yi. In conclusion, thus far the main systems have been completed this quarter. We've been able to do some preliminary testing and will be able to start modifications for a final test. In the coming quarter, we will work on the vessel connection system so that the hard link can be established, any final waterproofing, and final testing. Once this has all been completed, we can prepare a final design presentation for our client. Thank you.